You know, while our brains, our nerves, our muscles depend on the carbohydrate glucose for energy, and though we might be as immobile as plants if it weren't for the compact storehouse of energy that fat provides, it's proteins that gives the very shape to our bodies. Proteins form our hair and nails, and along with water, they are the principal substances in our muscles, organs, blood, and skin. Proteins form the collagens of the connective tissues that holds our bodies together and wraps our bodies in flesh. Proteins contain DNA. Most hormones and enzymes are proteins, and proteins all have the same basic structure. They consist of long chains of amino acids linked in a characteristic sequence. Do you see a pattern here? We had the carbohydrates, which were long links of monosaccharides, glucose isomers. Then we had fats, which were long hydrocarbon chains ending in a carboxylic group bound together, at least in triglycerides, by glycerol. And now we have proteins, which are called first among equals. And they probably are the most representative of a natural polymer. We may be familiar with plastics that I'm sorry, we all are familiar with plastics for good or bad, but we may know that they are polymers. They are long chains of the same repeating or the same type of repeating unit. Amino acids are those units, and we have a limited number of amino acids, and they all look like this. They have, for example, a central carbon atom here, okay, a carboxylic acid group right here. What is that? I don't know. Sorry about that. Okay. Ah, an NH2 group. This is the first time we've seen anybody besides carbon, hydrogen, and oxygen. Have you noticed that? All three macronutrients are primarily carbon, oxygen, and hydrogen. And then this is another one. We've got a hydrogen there, and then this little R is kind of like a generic, and it means a different organic species. All right. So, for example, for the amino acid glycine, R is hydrogen. For the amino acid alanine, R is the methyl group, the CH3. Right. I call this the choo-choo train. This is a nice rendition of how they go together. The properties of a protein depend not only on which amino acids are joined, but in what sequence and the total number. Proteins are natural polymers of amino acids, like I said. Look at this. There are over 100 billion different proteins on Earth. Our human bodies contain 50,000 different proteins. That is absolutely amazing. Okay, here are the two I talked about. Here's glycine, where that R was hydrogen, and alanine, where the R was CH3. They come together from the COOH end, and the nitrogen end is at the other one, and they hook up right here. It's called a peptide bond. And it spits out water. You notice how that's another one that's always happening. When we put the monosaccharides together, you spit out water. When you when you put these together, you spit out water. And it's not going to be just two. Here is a primary structure of a protein that is the order of the amino acids in this chain. Okay, what does that say? Each one of these, they use a 3-letter code for the amino acid. All right. For the amino acid. And they are trying to decipher many different kinds of proteins, and make a huge library out of them. And I believe this is being done in a Norwegian country. I'm not sure which one. I'm sorry, not Norwegian, a Scandinavian. Norwegian usually means Norway. Okay. All right. Now, we see that it very easily gets pretty complicated. This is a pretty simplistic uh, uh, protein. There's our end, our carboxylic end, and here's our nitrogen end. And they will link in hydrogen bonds across each other like that. Okay. We do not store protein. Remember, we can store glycogen. We can store, which is the polysaccharide. We store those in our liver and our muscles. We store um, blood uh, blood sugar, which is glucose in our blood, obviously. We store fat, some of us more than others, but we do not store protein. And we must supply our bodies with about 1 gram per zero point 0.8 kilograms, and it's about 45 for women and 60 grams per day to maintain proper health and nitrogen balance. Wait a minute, that's kind of interesting. This is our source of nitrogen. All right, this is our only source of nitrogen. We must keep a nitrogen balance. If you have too much, well, let's see, nitrogen goes out via urea, urine. All right. Nitrogen is very important for us to uh, maintain for many different uh, uh, systems in our bodies. And you need to maintain enough nitrogen. If you don't, you have a nitrogen deficiency, and this is called starvation. And the body will start to harvest itself. You literally eat yourself up. Remember that that when you starve, you've already used up all your fat, and your body will usually try to keep its organs for the last, and it'll go after muscle. Muscle is primarily protein. It is not all protein, it's more complicated than that, but it is a source of nitrogen. There are 20 naturally occurring amino acids, AAs. The human body, we can only synthesize 11. 9 must be consumed. That means eaten. Probably knew that. They're called the essential amino acids, if you've heard of that term. Meats contain all the essential amino acids in the same proportion as the human body, so they're called the perfect protein. Okay? But most people in the world depend upon grains, vegetables, legumes, like peas, for their essential amino acids. And people have figured out how to mix and match things that have some amino acids but not all. So they'll do a combo of different foods in order to get all these essential amino acids, like beans and plants, like soy. Oh, I'm sorry. Like, let's see. Let me think. Latin America, beans with corn tortilla. Asia, soy. Now it's a complete protein too. This is also called a complete protein. Soy is also a complete protein, but has very low concentration of some of the necessary amino acids, the essential amino acids. So what people will do in Asia is they combine soy with nuts or rice. Okay? The Middle East, you have Bulgar wheat and pita bread with chickpeas or sesame seed paste, hummus. In India, they'll put lentils and yogurt with flatbread. In the U.S., what have they done? Oh, how about peanut butter on bread, or black-eyed peas and cornbread? All these things coming together, they're called complementarity, where you combine foods that complement each other's essential amino acids content, so your total diet supplies sufficient amount. Right? So you get all the essential amino acids in the correct amounts.